Alright, so here we're tackling some more stuff that was sent to me. Because there's some typos that came up on this, I will kind of tackle it slightly differently, but that's okay. Let's take a look. Okay, so this was someone's old quiz, and we're just going over it to kind of just learn some more material from it. Okay, so it says, which bond is an alkyne? Okay, so alkynes specifically are molecules that have triple bonds in them. So this is your alkyne, easy, it is done. But let's take a look at some of the other functional groups that are present. So B points to the bond that's next to this oxygen. This oxygen actually makes up what we call the ether functional group. C points to the arene ring, which is just a cyclic alkene. And D points to an alcohol. But again, alkyne is a triple bond, so this is the triple bond. Okay, which of the following molecules contains a ketone? I like this because this asks what's a ketone, but these say alcohol. Okay, so let's forget the answer choices here. Let's just name these functional groups. First one here is an ether. It says an ether. The next one is an alcohol. And I do apologize, I'm doing this all with a mouse. The third one is a ketone. So let's forget the answer choices down below. These are their names. Ketone is a secondary carbonyl. An alcohol can be primary, secondary, or a tertiary alcohol, depending on the number of carbons that surround this carbon. Since this has one carbon attached to it, this is a primary alcohol. And ethers exist somewhere in the middle. It's just an oxygen thrown in the middle of a molecule. Okay, specifically between two carbons. Okay, so aspirin, cool. So aspirin is acetylsalicylic acid. So we see that we have salicylic acid, and it has an acetyl group attached onto it. So this is acetylsalicylic acid. But let's look at the functional groups that are present. So we have the benzene ring. This is called an arene. Arene, that is an E in the middle. Okay. We have a carboxylic acid. Silic acid. That is disgusting. Okay. Here we have an ester. So this is not an ether, but an ester. An ester is basically a carboxylic acid where the hydrogen is replaced with another carbonyl or carbon group. Okay, so let's look at the answer choices. Benzene ring, cool, cool, cool. Phenol is a benzene ring with an alcohol on it, so no, that's also not technically a functional group. So benzene ring, we see an ester. You don't have any ketones, so I don't know why that's there. Ether, ketone, it's not an ether, we have an ester. The ether and ketone smashed together is called an ester, so that's just not a thing. Yeah, and there is no alcohol, so it is this one, it is D. Okay. Tetracycline is a common antibiotic. Classify each functional group in which the two box functional groups are correctly identified. Okay, so this one here is called an amide. Amide is like an ester, except it has an amine in place of the oxygen. And this one here is an amine. And amine does not have that oxygen. Okay, other functional groups that are present, I mean, we have alcohols, we have ketones, we have this, which is an arene, we have an alkene. In fact, this is a conjugated alkene right here because this can have resonance. It can also have resonance this way. Okay, let's see the compound below. Cool. So condensed structure basically says, let's forget all these bonds between hydrogens. Let's just write it out. So I can write CH3 or H3C, it does not matter, is bonded to a COO. Actually, it is bonded to a COO. This is bonded to a CH2. And this is bonded to a CH3. If you want to do a structural formula, you would write this as CH3. And this is where I was starting to mix things up. COO, CH2, CH3. Okay, cool. So this is the formula. This is the structural formula. Like this is a structure, basically. So you have a structural formula and you have a condensed structure, which is the formula but with bonds between the carbons, and that shows where oxygens are at. Okay, skeletal line structure then removes pretty much everything that's not an oxygen, or well, it removes anything that's carbon and hydrogen. So we have the first carbon bonded to the second carbon, which is bonded to an oxygen, bonded to an oxygen, bonded to a carbon, bonded to a carbon. Okay, so these two structures are the same thing, and the functional group in this molecule is an ester. Okay, provide the structure of the major organic products in the following reaction below. Okay, so let's go ahead and draw out what this molecule looks like. CH2, and this appears to be another typo because this molecule cannot be written out. There is no way for me to have a CH2 and then have an OH on it and then have a methyl come off because this is only one hydrogen. So my assumption is going to be is that there is a typo here and this should be CH. Otherwise, this cannot be solved. So anyway, so we have a phenyl group, or pH. Then coming off of this carbon is the CH, which coming off of that is the CH3. And the OH is coming off of here. So I'm going to make the assumption that this is what it meant, and it's just a typo. Okay, when this is reacted with this compound, which you should become familiar with because you'll need to use it a lot, it will replace the OH with a chlorine. So we end up observing this molecule. Okay, and basically what we're going to observe is that when this reacts with an alcohol, replace it with a Cl. We also have another Cl that's released because there's two of them in this molecule, and that O is associated with an SO2, so we got sulfur dioxide, and the hydrogen that I'm not drawing can be associated with the chlorine, so you can say it forms hydrochloric acid. So this reaction forms hydrochloric acid, SO2, in addition to a chlorinated molecule, where the chlorine is where the alcohol used to be.